I'm going to start by introducing you to Gus. Gus is our poodle pointer. As you see, he's a very handsome dog. Gus is a hunting dog who is a breed that was bred to be able to run for 10 hours at a time. Gus is an absolute loving nightmare in the home environment. And while my husband has him trained amazing for hunting, again, he's crazy in the house. So Gus and I needed to do some special training together. So you can take Gus for a 5-mile run and it doesn't take the wind out of his sails at all. What wears Gus out and exhausts him is when he needs to sit still and behave. So if we have company about to come over, what I do is I take Gus for a really slow, boring walk. So we walk, we stop, he's got to sit and hold still. 20 minutes of a walk with Gus, and he's exhausted for the next 2 hours. 5-mile run, it just winds him up for the rest of the day. And I had that moment of, oh my gosh, this is so many of the kids that we work with. These are our kids where their bodies are made to move and wiggle. And with young children, when you move your hips, it actually wakes up your brain to pay attention. But then we go to school and we ask the kids, what do we do? Sit still, don't fall out of your chair. We're sitting at the dinner table, right? We want to get through a nice family dinner. And what do we find ourselves doing? Hold still, pay attention, come on. Why can't you sit like this? And think again how much that applies to our kids. We ask them to sit through an entire school day and hold still and pay attention. And then we expect great behavior at home after doing that. But yet, for some of our kids, it takes so much more energy to hold still than it does to pay attention. All right, so we're going to start with what is the definition of attention. It's the act or power of carefully thinking about, listening to, or watching someone or something. It's a primary cognitive function that's necessary for learning and interaction. So when we think about when a child's sitting in a classroom, what are all the aspects that go into being able to pay attention and focus in the classroom? So we're sitting there and we've got a ton of noise happening around us, right? I can control my own body to a certain degree, but I can't control how much noise the kids are making around me. I can't control the visual distractions. There's a few things that we have a little bit more direct control over. So things like how much sleep you got the night before. What we eat has a huge impact on our ability to pay attention and focus. Also our stress management. If I'm worried about something, like whether or not my computer's working and doing what it's supposed to do, then that's going to pull some of my attention and focus from the task at hand. So those are pieces that we can work to minimize for our kids. So being super aware of how much sleep, also for ourselves, and what they've eaten. I'll have a parent say to me, you know, when my child's doing something that they love, they've got great attention and focus. So if they're playing a video game, why can my child spend 2 hours playing a video game, but then I ask them to sit down and do math and I can't get them to sit down. I can't get them to cooperate. I can't get them to hang in there. Those are two very different types of attention and focus. And so the fact that a child can play 2 hours of video games does not mean that they're capable of 2 hours of sustained attention and focus. Those are the short-term reward-driven pathways. And what's interesting is whatever part of the brain we're using is the part of the brain that we're training and building and making stronger. So when our kids are spending a ton of time, and us as adults, because the brain can change at any age, we're training these short-term reward-driven pathways. So we're needing a constant reward to keep us paying attention and focusing. So really what we want to pay attention to are our sustained long-term attention pathways. These are the attention pathways we need to do to get through really boring things. So if you're sitting in a biology lecture, you're reading a book that isn't animated. And so I need to have the ability to stay tuned in and focused. 8 hours in a classroom of sitting still. Our kids need sustained pathways, but yet we're spending so much of our time all day, every day, doing these instant gratification pieces. And so that's one of the things that I challenge you guys in yourselves and for your kids is think about, are we getting stimulation on a daily basis in the long, boring things? So doing things like, you know, having a child mow the lawn. I should make the kids cover their ears. Chores are so great for sustained pathways. Doing things that are just take a long time. Painting a fence, planting a garden. They don't have to be all negatives. But just things that require long-term attention and focus, we need to make sure that we're doing those things on a daily basis as well because we're getting a ton of the short term. Really, what we're going to focus on here today is where attention and focus comes from. It is not something that we're all born with. In fact, babies have zero attention and focus when they're born. And what we're realizing more and more through science is our development of attention goes hand in hand with our development overall. And so when we see great attention and focus, that's a good sign that we've got great development. When we've got attention and focus that does not present as age appropriate, or attention and focus that's a little more on and off, or needs more redirection to be on task, that's a red flag to me that there might be some gaps and holes along the way in development. And we have a tendency as parents to look at body age and say, Alejandro, you're in 2nd grade. I think you should be able to do this. And in so many ways he is, but all of us have strong areas of the brain and areas of the brain that could be stronger than what they are. And like John was mentioning earlier, you don't need a label or a diagnosis in order to have the ability to make things better than they are. So one of the things, again, that I'm going to challenge you to do today as a parent is if you have a child that you're worried about, don't think about their body age, watch their development. Watch how it lines up with other kids and set your expectations on where your child's at. Meet them where they're at, and then we're going to work to move them forward from there. So that way we're placing realistic expectations on the kids. So how does development come together? So we're all born, and when we're born, we should be born with a set of healthy primitive reflexes. What does that mean? When you touch an infant's cheek, they turn to latch on so that they can eat. That's there as a survival mechanism. Then the more we mature and develop, a huge part of development is learning to inhibit or turn things off so that I can control things. An infant doesn't have any control. When an infant moves an arm, they move both arms together at the same time. So as we're born with these primitive reflexes, we start to eat and drink and swallow, so we're building the muscles that are eventually gonna allow us to start to speak. And the more mature we get with the brain, the more the brain turns that off. So if I were to walk up to Carol right now and touch her cheek, it would be really awkward if she tried to latch onto my finger. So beyond 2 years of age, we're hoping that Carol's not awkward like that. If she is, we've got a program, we can help. But again, then that gives you control. So if we have a child that tends to be messier with their eating, or when you switch over to handwriting, that's a reflex as well. The child that holds the pen in a different way, or they push super hard, or their spacing is off, that's a sign that there might still be a reflex present, so they've got less of an ability to control that. So that's one of the first pieces we look at. Then what we know about the brain is two of the strongest engagers of developing the brain are our muscles and our senses. So with an infant, the more, or toddler, the more they run and move and play, and they're crawling on the carpet and then on the sand and in the grass, all of that sensory input and using all of those muscles is what continues to build and grow and develop the brain. Then we start to get something that we call body awareness. So my body awareness is how I'm able to close my eyes and touch my finger to my nose. I can sense and feel my body in space. And we need that so that I can read your nonverbal social cues. And so if we have a child that's not picking up on their social cues, they're more into their own immediate needs, that's a developmental piece. And so that shows me that child needs more movement, more sensory input to continue to build and mature and develop that brain. Then we get to our eyes. Our eyes are a huge indicator of the success of our attention and focus systems. And top neurologists in the country right now are all focusing on the timing mechanisms in the brain and our eyes, how our eyes move and connect and coordinate. And in order for my eyes to successfully and accurately track, I've got to have all of my attention systems in the brain working perfectly. So what we're able to do is by having kids do eye movements and tracking, we're actually training the brain to increase and enhance attention and focus. But in order for the eyes to do what they're supposed to do, brain's got to be able to sense and feel motion. So it's that whole kind of series of events to get us from one place to another. There's some really great research out there, and we've got a ton of exciting research happening at Brain Balance. But what we see is if primitive reflexes have not been outgrown, if those baby reflexes are still present, we're going to see much higher rates of struggling with attention and focus. If there's any sensory motor pieces, and what that means is a child that processes sensory information too much. So really particular about tags or textures or touch. Or a child that is a little more discoordinated in their movements. Again, we're going to see a higher rate of struggle with attention and focus. So what we're able to do with that at Brain Balance is we understand that these pieces are what drives attention and focus. And so rather than asking our kids to sit still and pay attention if they don't have the ability to do that, we're going to go back and build the parts of their brain that naturally lead to increasing that attention and focus. So 2 key pieces happen with the development. The first is we've got to develop the networks and pathways. So we're born with a brain with all of these cells, but I don't have the ability to access everything. And so our brain needs to make these connections so that I can control and coordinate my body. In addition to that, we need to develop the control of those networks. So first we've got to build the networks and pathways, and then we have to have the ability to control those. So how do we build those pathways is, again, through our senses and our muscles. And what learning is in the body, so when I'm trying to build a new pathway, so that way you can access the part of the brain. So for example, you're trying to learn how to tie your shoes, right? That's the thing that we want everybody to be able to do by kindergarten. And that takes the coordination of 10 little fingers all working together with 2 shoelaces. So tiny little dexterity there. That's a ton of motor planning, a ton of sequencing that has to happen to tie your shoes, right? It's not an easy thing to learn. And so we do it, and we do it over and over and over. You and I, if I asked you to tie your shoes, you could tie your shoe without even paying attention. That's when a network or pathway is there, when you can do something without thinking about it. But when we have a child that is struggling to do something, that shows me that that pathway isn't there. And so again, we're able to use senses and movement to engage more areas of the brain, and then we do that over and over and over, so that way that pathway is present. So that's how we start to push development forward from that bottom up. We all have thoughts that go through our head that should not come out our mouth. We all have times where we want to squirm and fidget or wiggle, but I'm in a dress, so I shouldn't do that. So inhibition should stop us from thinking and saying and doing the things that aren't appropriate in an environment. A 2-year-old doesn't have inhibition. A 2-year-old in the grocery store, if it itches, wherever that is, they're going to scratch. They're going to sing, they're going to dance, they're going to say whatever comes to mind. For everyone, as we mature and develop, we start again to develop that ability to control. So I'm only doing and saying what I should when it's the right time. So as we build and mature the system, it protects our brain, so that way we get to save that energy for learning in the classroom, paying attention, listening to what my friend has to say, and making the decision of what are we going to do next on the playground. So it's that emerging inhibition. And we see it in our thought and action. A thought scientifically is the same thing as an action. So if we have a child that's too much movement, too wiggly, too fidgety, more than what they should be for that age, that's an outside glimpse of what's happening inside. If they're too busy on the outside, it's going to be really busy on the inside as well. And so what we want to do to mature that is, again, build those pathways so that the brain is able to block out that extra information. When we're mature in our systems, I can focus in on you. If you and I are having a conversation, and I can block out and ignore everything else. The kids that we work with don't have the ability to do that. They see everything in the room equally, which means their brain is processing so much more information all day, every day than what it should. That's exhausting. That's going to drain resources. So now I have fewer resources to handle myself when I start to get frustrated and upset. Can I rein it in? Tired brain can't control. We also see it in noise. So if I'm sitting in the classroom and the kids next to me are talking, a mature brain is able to tune that out and block it out. But so as we develop inhibition, I think of it as the bike helmet for the brain. Our mature brain protects us from having to process more sound, more visual input, more decision making. The mature brain just does that naturally. We don't think about it. It just happens for us. And we assume that because my brain works that way, we make the assumption that your brain works that same way. Our kids' brains are very different from ours. And so that's something that we want to keep in mind. So what does it look like if we have areas of gaps and holes in development? What does it look like if the attention networks and pathways haven't come together? I'm going to introduce you to Ryan. Ryan is in school with my son, and so I met Ryan as a kindergartner. And my son came home from school. It's probably about the first month of the school year, and my son came home and said, "Mom, can I get your business card?" He's in kindergarten. I asked why, and he said, "I got to give it to Ryan." So I said, "Okay, hold on, back up. We can't do that." And I said, "Why? Why does Ryan need my business card?" And he said, "Mom, he tries so hard, but Ryan gets marks on his card all day long." Ryan is just spitfire, full of personality, huge grin on his face. It would be really difficult to be a classroom teacher because with Ryan, it was Ryan, in your seat. Ryan, finish your lunch. Ryan, you can talk to your buddy after that. But with a huge grin on his face the whole time, like you love this kid, but it was just constant. So fast forward a couple years and I'd come to the school to visit and you'd see Ryan walking down the hall carrying a stack of textbooks. And I'd say, buddy, what's going on? Running an errand for the teacher. No, the teacher was letting him get out of the classroom and move so he could come back in and focus. And Ryan's mom reached out to me the end of 2nd grade. And she said, I got to do something. And she knew a little bit about what I did, not a lot, so she wanted to know a little bit more. And they were having a family dinner one night, and Dad left the table upset and mad. And Mom was tucking Ryan in at the end of the night, and they were talking about Dad being upset and mad, and Ryan said, Dad's mad because I'm a bad kid. And Mom said, no, Dad has lots of other things going on, but it had gotten to a point where, you know, constant redirection, that's what Ryan felt about himself. And he was starting to struggle in school. Mom was getting literally weekly phone calls, emails, extra conferences, and so she said, we got to do something. I don't know what else to do. All of us have struggles. We all have areas of strength. We all have areas that could be better. And that's really what our focus is at Brain Balance, is figuring out what are the areas that aren't functioning as efficiently and what can we do to drive that forward. So how we do that at Brain Balance, we work with kids, so we want to keep it kid friendly. So we are using our senses and our muscles and computer games and fun things to target areas of the brain. If a child's struggling in reading, we're not having them practice what they struggle in, we're changing why that didn't come together in the first place. Why aren't their eyes tracking the way they're supposed to? Why is their attention and focus fatiguing so they can't remember and retrieve what it is that they just read? So we do that through physical and active things. Something that, again, we're incredibly proud of and so excited about the research collaborations we have going on right now. The McLean Hospital out of the Harvard Med School, we've got an ongoing study there. And what I love about this study is they did Brain Balance, they did it at home, so it is only a fraction of the actual program. And they did pre and post functional MRIs with these kids. And for me, it was one of those like full body goosebumps moments, because for 10 years, I've watched these change happen in kids over and over again. And then I got to see the change in functional MRI. I got to see the difference in the brain. And the lead doc for this, Dr. Teicher, he said to me, what do you think changed? And I said, well, I think we're going to see, and this is me trying to talk to a Harvard neuro guy, right? I'm like, I think we're going to see more stuff here and a little more here. And it was exactly right. So what we see play out in the symptoms with kids changing was reinforced with the parts of the brain that we saw changing. There was increase in blood flow and connectivity in the frontal lobe. That's executive function. That's attention and focus. It's good decision making. It's impulse control. It's organization, prioritizing. It's planning. We saw huge change in an area of the brain called the amygdala. That does our emotional processing. Yeah. And so we all get stressed and frustrated and upset. How do you handle yourself in that moment? And so we saw increased connectivity in the area of the brain that controls that. So when we build connections, when we mature inhibition, what does that look like in real life? So this is Ryan. The boys are now 5th graders. So Ryan did the program at the end of 2nd grade. He was struggling academically. He was in trouble all the time. And Ryan now he goes a year up for all of his reading and math and core classes. And this part always gets me. It's, you don't need straight A's to be successful in life. It's feeling good about yourself. The only teacher conferences that they have at this point are the annual scheduled ones. As parents, we want to set our kids up for the best success possible in life. We all have areas that we can strengthen and improve. And the kids that we work with are awesome kids. There's nothing broken with them. There's nothing wrong with the kids that we work with. There's just the potential for things to be better. And when we strengthen and mature and improve those pieces, there's better regulation, there's better control. And it's enough change that the kids can often really feel and tell the difference and verbalize it themselves. But it's not just about function, it's about lifestyle. So we want to make sure that we're educating and supporting, so we're teaching our kids today, what are the tools you need for success going forward? When you build pathways in the brain, they stay, they don't go away. It's like learning how to ride a bike. Once you've got it, you can go 10 years without riding a bike and you still have it. But lifestyle adds on top of that. And so if we can teach our kids that when we exercise and when we move, it turns on our brain. So that's what we're going to talk about now, are kind of what are some of the things that you can do now? What are concepts that we can implement in our life? I can't say enough. We use our muscles to turn on our brain. Our muscles set the idle speed for our brain. And so the best thing we can do in the morning is to move. And so if I've got a kiddo that has a hard time in school, starting the morning with even just 3 to 5 minutes of exercise is going to turn on and rev and fire the brain. It's going to wake up the brain that does attention and focus, good decision making. And then 1-minute brain breaks throughout the day. So if you have a child that sat all day in school and they come home and now they've got to do homework and we need them to sit any longer or even longer, every 15-20 minutes, give your child a 1-minute wiggle break. In the beginning, it's going to take some getting used to. The kids can be wild and crazy with it and it's hard to rein them back in. It will become routine. And there's a great book, Spark. Spark talks a lot about when we use our muscles, it can increase memory for up to 20%. It increases attention and focus. And so while we want to just buckle down and get the homework done and out of the way, it can be more productive if we break it up into smaller chunks and add movement. When we're not moving, it's turning off the part of our brain that does emotional regulation. So if I've just spent 2 hours playing a video game, that's a ton of processing that my brain's going through. So that's gonna wear down and exhaust my brain. And then I'm not moving, so I'm not turning on the part of the brain that does emotional regulation. So when we come off that video game, we're gonna tend to see more in the way of negative behaviors. So the no and the pushback when we say, buddy, time to turn it off, isn't just because they don't want to stop playing that game. They've turned off the part of their brain that allows them to control their behavior. So as parents, we need to know and understand that if we allow a couple hours of video game to play, we need to expect really negative behaviors after that. So if we want to set our kids and family up for success, we've got to balance that. So shorter increments. We don't want to do 2 hours of video game, and then we want to counter that with movement before and after. And so if you're going to play a video game, go for a bike around the neighborhood, and then when you're done, tell me what you're going to do to move to turn off afterwards. Another thing that's really important is heart rate variability. So when we start to get really stressed and frustrated and upset, our body goes into what's called fight or flight mode. We've got a calming mechanism of our body that brings that back down. It happens too if we exercise and go for a run. It's that calming mechanism of the body that brings our heart rate and our breathing back to normal, back to calm. And so doing heart rate variability exercises with kids, having them run around and then recover that heart rate, actually builds and strengthens that calming mechanism in the body. Play freeze tag in the yard, chase them, run around. It's good for our brain and body as well. But finding ways to spike heart rate and then give recovery time. So again, what you can do now, we can move, minimize screen time. What you eat matters. All of our body burns the nutrients that we put in it. When we're having good healthy fats, it takes our body a long time to burn through fats versus sugar and carbs we burn through really quickly. Protein is also something that helps us to stabilize that process. So one of the things we've really noticed with our own kids, my daughter Morgan is a really calm kid until she's gone too long without protein, and then she's whiny and she's negative. And you watch the second she starts to get to that point, which is really unpleasant for everybody. You plug protein in her and 20 minutes later, she's back to her sweet, happy self. And so for us, survival mechanism as a family is this kid needs protein at breakfast, snack, lunch, snack, dinner, and healthy sleep patterns. Cambridge Brain Science is one of the groups that we're collaborating with on research, and they just did a 40,000 person sleep study. And what was fascinating in this sleep study is they saw sleep deprivation that can happen just in the span of one night, and cognitively we can function as though we've had 2 to 3 glasses of wine. And so sleep deprivation impacts us the same way as alcohol. And so if we have kids that stayed up too late the night before and we're expecting them to behave the next day, we're not setting them up for success with that. And so sleep matters. Another piece is just a super simple thing, but how we sit matters. Again, our muscles set the baseline for attention and focus in the brain. So when we're slouching and we're using as few muscles as possible, that allows my brain to idle at a slower speed. We're gonna get more tired and fatigued. So the old adage in the classroom of sit up to pay attention, when we engage our core, it wakes up our brain. So when kids are doing homework or when you're sitting at your desk doing work, that's why stand-up desks are so popular right now. now, and companies are paying for them because it increases work productivity. So think about that with your kids and yourselves. Again, can you stand? Can you sit on an uneven surface like an exercise ball so it's engaging the core? Can you sit on the edge of the chair so you're engaging your core? If you're sitting in a biology lecture and getting tired, what you can do if you're tired is, again, sit up and engage your core to wake up your brain. And Brain Balance has a ton of great resources for parents. We have great resources, downloadable resources that we can email out to you. Sleep, for what age, how much sleep is needed at different ages. Just great tools and tips and suggestions for at home. Also classroom resources if you are an educator. The Brain Balance assessment takes about an hour and a half. It's unlike any other assessment that you've ever done, and it provides you with a ton of information. You're not obligated for anything doing the assessment. It's going to show you where are areas of strength and challenge for your child, so it allows us to create a custom game plan of how do we build the parts of the brain that aren't functioning at the level that we'd like. So again, if you're like Gus and you need to move to pay attention, that's one of our specialties of being able to really help to mature and build the brain so that we've got better attention and focus, better control, but we're able to really make some fantastic, exciting life changes for the kids. So thank you so much.